This is a continuation from the first four problems in a set of examples on separable differential equations. Kung sa YouTube mo to pinapanood, may lalabas na link sa taas para sa part 1. Tuloy tayo sa number 5. We want to find the particular solution to cosine x times secant squared y times dy over dx equals cosecant squared y secant x with the condition na y of 0 equals pi over 4. Simulan natin by grouping together lahat ng factors na may y sa kaliwa, kasama ni dy, at lahat ng may x sa kanan, kasama ni dx. So we have secant squared y over cosecant squared y dy equals secant x over cosine x dx. The left side simplifies to tangent squared y dy. Equal siya sa secant squared x dx. Integrate natin both sides. Using a Pythagorean identity, isulat natin si tangent squared y as secant squared y minus 1. Evaluating the integrals, we have tangent y minus y equals tangent x plus a constant c. Applying the given initial conditions, we find na si constant c ay equal sa 1 minus pi over 4. So ang particular solution natin ay tangent y minus y equals tangent x plus 1 minus pi over 4. For a more exciting problem, hanapin daw natin ang lahat ng curves na perpendicular sa y equals k times the cube root of x for all values of k. May dalawang set of curves dito. Si A na given sa atin at si B na hinahanap natin na perpendicular dun sa curves kay A. Since ang perpendicularity ng mga tangent lines ay based sa slope, hanapin muna natin yung expression for all the slopes of all the curves ni A. Ibig sabihin, kukunin natin yung derivative niya. So y prime is equal to k over 3 times x raised to 1/3 minus 1 or negative 2/3. Note that k is equal to y over the cube root of x pag in-isolate natin siya. So si y prime ay equal sa k, pero k is y over cube root of x times 1/3 times 1 over x raised to 2/3 or the cube root of x squared. This simplifies to y over 3x. So ito yung differential equation describing A na solution si A. Since perpendicular si B kay A, ang slopes ng tangent lines niya ay negative reciprocal ng slopes ng tangent lines ni A. Meaning yung dy over dx ni B ay negative reciprocal ng dy over dx ni A. So for B, y prime equals negative 3x over y. Solve natin by separating the variables and integrating both sides. We have y squared over 2 equals negative 3x squared over 2 plus the constant c1. Multiply everything by 2 and rearranging terms, we have y squared plus 3x squared equals a constant c na galing dun sa 2 times c1. Let's plot the two families of curves to verify our solution. Si orange yung given na y equals k times cube root of x. Si purple na ellipse, siya yung y squared plus 3x squared equals a constant c. Pag 0 si k, tama naman na perpendicular si ellipse kay y equals 0. Pero kahit palitan natin yung value ni k, notice perpendicular pa rin siya sa ellipse dun sa points of intersection nila. Kung ang value naman ni c yung palitan natin, we will notice the same thing. Kahit simultaneous natin sila palitan, perpendicular nga lahat ng curves ni generated ni ellipse equation dun sa cube root functions natin. Except sa origin, kasi hindi naman defined yung ellipse sa origin. Wala tayo dong curve. Natatama sa point ni cubic function sa origin. Kaya kailangan natin idagdag si y equals 0 para lahat na ng curves, masama siya dun sa lahat ng curves na perpendicular sa k times the cube root of x na family of curves. Bali yung ellipse, pwede niyang tamaan yung cube root function natin except when x equals 0 at the origin. Finally, let's see how to solve the differential equation na first example dun sa previous video. Again, hindi ito separable na differential equation. Dahil si y double prime at y prime at y ay nag-add up to 0, ibig sabihin, may common factor sila. At yung function na nagkakaroon ng common factors ang derivatives ay ang exponential function. So we let y be equal to e raised to rx y prime is r times e raised to rx and y double prime is r squared times e raised to rx. Substituting these expressions sa differential equation natin, we have r squared times e to the rx plus r times e to the rx minus 6 times e to the rx equals 0. Pwede natin i-factor out si e to the rx. Since e to the rx is always positive, wala siyang effect dun sa solution ng equation. So solve na lang natin yung r in the quadratic part and we'll have r equals negative 3 at r equals 2. So parang sinasabi sa atin na ang possible solutions ay y equals e raised to negative 3x at y equals e raised to 2x. Pero pansinin, kung magmumultiply tayo ng constant sa kanila like so, magmumultiply ka lang din nung same constant sa 0. So solution pa din kahit maglagay tayo ng constant sa harap. And in fact, kahit kunin mo yung sum nilang dalawa, mag-add up pa din to 0 yung differential equation pag na-substitute na sila dun sa differential equation. So, etong expression na to ang general solution para dun sa ating given na differential equation. Note na sinama ko lang to para makakita naman tayo kung paano mag-solve ng ibang type ng differential equation na hindi lang yung separable na type. But as far as the coverage of this quarter goes, hanggang separable differential equations lang tayo. So, hindi to lalabas sa exam. Yeah, for now, salamat sa pakikinig.